Hi, today we're going to be looking at comparing and ordering numbers. So let's get started. The first thing we're going to be looking at is the number line, and let's understand what the number line is for. The number line is a line that has numbers going across from left, oh, from left all the way to right. And the purpose of a number line is to gauge the size of different numbers as they relate to each other, okay? The one important thing that you want to think about whenever you're creating a number line is recognize that the increments that the numbers change by have to be identical. So in this case, the increments between every different dash here is 1 million. So we start at 1 million at one end and we finish all the way to 19 million. You could start 1 to 10, you could go 1 to 100, you could go 100,000 to 500,000. It doesn't matter. What's important, however, is the increments have to be equal. So in this case, every difference is 1 million. So 1 million to 2 million, 2 million to 3 million, 3 million to 4 million. Okay, great. Now let's look at how we could order numbers on this number line. So if we think of three different random numbers, so let's say 3.8 million is one number, 17 million is another, and let's do 0.5 million. Okay, so this one's probably the easiest one to plot. Okay, if we were to plot 17 million, it would fit right here. That's pretty easy. That's 17 million, right? If we were to plot 3.8, it's a bit harder, but it's not too hard. We know that the 3 million is right here and the 4 million is right here. 3.5 would probably fall somewhere here. Okay, so 3.8 would probably be right here. And the 0.5 million, well, that's under 1 million since this is 1 million and this is 0 right here. 0.5 would probably be somewhere around here. So 0.5, this would be 3.8, and this would obviously be 17. Cool. Okay, let's look at some other examples. Here we have 8 countries with their respective populations, and let's start plotting these populations, these numbers, onto our number line. So let's start with the country of Cyprus. Cyprus has a population of 1.17, so this is 1, this is 2. Well, 1.17 is close to 1.2. I would say it's about here. Remember, this is a guess. This is an estimation. It's roughly around here, give or take a little bit, maybe here, maybe here. But generally speaking, it's about here. Senegal is at 15.59 million, so almost 15.6. This is 15, this is 16. 15.6 would probably fall around here. Syria, 18.56 would probably fall around here. Cuba at 11.39 would probably fall around here. Sweden at 9.85 would probably fall around between 9 and 10, but it's really close to 10, so probably around here. Denmark 5.69, so 0.69 is larger than 0.5, so it's past the halfway, but it's not quite there yet, so probably maybe around here, almost 3/4 in. Latvia at 1.95. 1.95 is super close to 2. So this is 1, this is 2. Latvia is very close to 2. It's almost 2, but not quite. And Armenia, 3.03. It's just a hair above 3. So this is 3 million. It's just like a hair above 3. So it's probably right here. Cool? So we've got the different countries plotted. Now let's try ordering these countries, right? So let's do this very simple question here. Order the following populations in order of smallest to largest, right? So here they're all mixed up, right? How would we order them? Well, we kind of did that in the previous presentation. We kind of ordered them. But if we were just to do it without a number line, well, we probably know that this is the smallest, right? Because it's a 1, and so is this. These two are really close, right? Remember, they were here and here. So this is the smallest. Cyprus would probably be number 1. Latvia would be number 2. And then what comes after 1.95? What comes after 2? Well, 9 is big, 5, they're all big. Oh, Armenia is pretty close at 3. Then after that, I think the 5.69, which is Denmark, would probably be the 4th. And then it'll be Sweden at 9.85, then Cuba at 11.39, then Senegal, then Syria. I think I got that right. Let's check out the answers. Cyprus, number 1. Latvia, number 2. That's correct. Armenia, number 3. Denmark, number 4. Correct. Sweden, number 5. Correct. Cuba, number 6. Senegal, 7. And Syria, number 8. And here they are ranked from smallest to largest population. Great. Thank you. Hi, today we're going to be exploring multiples. So let's get started. The first thing we want to know is what are multiples, okay? So to do that, let's look at two numbers, okay? 3 and 4. Now, real simple, multiples are numbers that are divisible by the number of that number that we're looking for. So in the case of 3, the multiples of 3 are any numbers that are divisible by 3. Well, let's have a look. What do you think they are? Well, 6 is a number that's divisible by 3. 9 is a number divisible by 3. 12 is a number divisible by 3. And you're probably seeing a pattern here. The difference between each number here is 3, correct? And essentially all I was doing is multiplying this by 2. So 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 15 is the next one, 3 times 5 is 15, and so on. And you could find multiples this way, and you could go on forever. So 18, 21, 24, 27, 30, 33, 36, and this is really easy, and you could go on forever and ever and ever. And these are multiples for the number 3. Well, if we were to do the same thing for 4, it'll look like this: 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. And again, you'll see that the difference between each step here is actually 4, correct? So these are the different multiples. These are the different multiples of 3 and 4. Now what we want to do is, and this is a task that you'll be doing frequently, is finding common multiples, okay? Common multiples. And common multiples in a set is essentially the multiple that is common between the two numbers. So what we want to do is we want to find the multiples that are common between of 3 and 4. Well, let's have a look. 12 appears in both these sets. So 12 is a common multiple of 3 and 4. The next number here is 24. 24 is a common multiple of both. And 36 in this set. Obviously, if I continued with the multiples here, I'll find many more multiples. But the common multiples here are 12, 24, and 36. So these are the common multiples of 3 and 4. Okay? It's really important to note, and this is really important, and that's why I have it in red here. I'll put a star to it as well. Remember the definition of a common multiple. Any common multiple of 3 and 4 would be divisible by 3 and 4, because a multiple of 3 is any number that is divisible by 3, and a multiple of 4 is any number that's divisible by 4, and a multiple of 5 is any number that's divisible by 5, and so on. Okay, so let's do some questions together to really solidify our learning. List the first 10 multiples of the following three numbers: 3, 7, and 8. Okay, so let's have a look. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Did I do 10 here? 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. 33, right? I just added 3 to the number. 7 is going to be a bit more difficult. Let's have a look. 14, 21, 28, 35, 42, 49, 56, 63, 70. And here, well, 77. And here we've got 16, we've got 24, we've got, well, what's 24 plus 8? 32, we've got 40, we've got 48, we've got 56, we've got 64, sorry, 64, 72, and 80 and 88. These would be the 10 multiples of the following three numbers, 3, 7, and 8. And all I did here is add 8 in each case. I added 7 in each case, and I added 3 in each case. Pretty easy, right? Okay, let's do one more. Find the first three common multiples of the following sets. Well, let's do this. So we've got 2, 3, and 4. Now we need to find common multiples. In order for us to find common multiples, we have to find the multiples first of each number. So 2 would be 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I could go on, but I think that should be enough. 6, 9, 12, 15, 18, 21, 24, 27, 30. Here we've got 8, 12, 16, 20, 24, 28, 32, 36, and so on. So let's find some common multiples. Well, 12 appears in all three, so that's one. The next one would probably be, interesting. I think we have to go on. So if we do 33 here, 36, this would be 24. So the next one would be 24, unless I missed any. See, 16 is common between 2 and 4, but not 3. 15 is itself. 18 is common between 2 and 3, but not 4. So 36 would probably be the next one if we continued this. So 24, I'm just gonna continue this here. So 24, 26, 28, 30, 32, 34, and 36. And 36 would be a third common multiple. Okay? I might not do the first three common multiples for the next one because I might not have enough room, but I think you get the idea. So 4, 5, and 10. This would be 8, 12. Again, they're all right here. 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. This would be 10. This is really easy, the fives, because you're just counting by fives here. 30, 35, 40, 45, 50. And here it's again super easy because you're counting by tens. So 40, 50, that's a 4, 60, 70, and so on. And to find common multiples, obviously the first one would probably be no, not a 10. Ignore that. The first one would be a 20, right? And 40 would be the second one. Yeah, ignore the 10. And then if we moved on, it'll probably be 60. 60 would probably be the next one. So if we do this, this would be 56, 60. And here we'd have 55, whoops, and 60. And here we would have a 60 as well. So 60 would be the third one if we went on. So that's how you find common multiples in sets. Thank you, and I hope you enjoyed watching.